sorry.
Oh, no problem. Thank you for having me. And thank you to those of you that have shown up on a Saturday night. I'm impressed and very appreciative for you all taking the time to be here. So tonight I want to talk about statistics and query plans, and this is a topic that I really love to talk about. So I sometimes get a little excited and I start talking a little fast, and if that happens, just raise your hand and tell me to slow down or ask if I could go over something again. I'm happy to do that. Hopefully I will be seeing those questions as they come through. You guys, Debbie and Sarah, you should feel free to interrupt me. I assume you can see my screen, correct?
Yes.
Okay, perfect. So just a little bit about me on this slide. The most important thing here is my email address, which is erin@sqlskills.com. If you've got questions about this session, please feel free to email me. If you don't get them asked during the session, I'm happy to follow up with an email reply. I work for SQL Skills, and if you're not from the company, the owners are Paul Randall and Kimberly Tripp, and then the other members are Glenn Berry, Jonathan Cahias, and Tim Radney. And we provide training through our immersion events throughout the US, in the UK, and in Australia. We provide training online through Pluralsight, and we provide consulting and remote DBA services, and we present at conferences. 2 weeks ago, I was at the PASS Summit, and Glenn was there, and the rest of the team was at Intersection. And if you want to hear from the SQL Skills team on a regular basis, you can sign up to be an insider. That URL is down there at the bottom. These are the classes, information on being a new client. If you're interested in any of that, just go to the website. You can hit our training page or our services page. And if you're interested in seeing more of our training online, you can check out Pluralsight. If you email Paul directly, paul@sqlskills.com, and you mention the Saturday night user group that you were here and include user group Pluralsight code in the subject line, he will send you a code for 30 days free for Pluralsight. So if you've never checked it out, I highly recommend it. We've got over 50 courses on there at this point, all related to different SQL Server topics. So tonight we're going to talk about statistics, and this is the abstract. I'm not going to read it. I'm thinking that if you're here on a Saturday, you've already taken the time to read it. So we'll just jump right into our agenda, which is talking about how the optimizer uses stats, how we find that information, and examples where stats aren't great, and then what happens to our plans when statistics update. So I like to make sure that we're all on the same page in terms of understanding what statistics are. And this is information about the distribution of your data in a column or a set of columns in a table or an indexed view. So whenever you're thinking about stats, like sometimes we end up thinking like on a really technical term and maybe a class we took in college, but stats, when we talk about them in terms of SQL Server, is really understanding what the data looks like in your database. Is it evenly distributed? Is it very skewed? And you would look at this using the histogram for a statistic. And I like to think of a histogram like this. Like when we look at it in SQL Server, it's a bunch of numbers. But if you took those numbers and you turned it into a graph, this is what you would see. So along the bottom, we have last names. And along the vertical axis, along the y-axis, we've got a number, right? How many people have the last name of Alexander? Or how many have the last name of Chapman? And based upon that count, that gets graphed. And this tells us what the distribution of last names looks like, right? Martinez is a more common last name than Ray, for example. And this is the type of information that gets used by the optimizer. Now, how does this get created? Well, every index that you create, every filtered index that you create, every indexed view that you create has statistics created automatically. That happens in the background by SQL Server when you create those objects. And then there are statistics that get created for individual columns. And these can get created automatically, and these can get created manually. So they'll get created automatically when you query a column or when you join on a column that is not the leading column in an already existing index. So if I had an index on last name, but I didn't have one on first name, and I said in my query where first name equals Joe, then a statistic would get created on first name so that the optimizer would have some understanding of what the distribution of first names would look like. Now, I can also create statistics on columns manually. They're a separate object. It's not part of an index or anything like that, but I could just create a statistic on an individual column. And I can also create them on multiple columns, and that only happens manually when you create a statistic on its own across 2 or more columns. Now, I can also create a filtered statistic, and this can be separate from a filtered index because a filtered index is a subset of data with a where clause in the index definition. And I can have a statistic, which is basically the distribution of data with a where clause in there as well. And that gets created. That is something that you would create manually as well. And so to look at statistics, you can do this in the UI, but you can also use the sys.stats catalog view. And I like to use T-SQL because I can take a script, save it, and use it over and over again, and it's faster than using the UI. So sys.stats is a good place to start. But you also have sysindexes, stats date, and DMDB stats properties, which is a DMF, which was introduced in 2008 R2 SP2 and 2012 SP1, and then it's available in 2014 and 2016 as well. So now how does the optimizer use statistics? Well, for every single query that you submit, the optimizer looks at that query and it generates a plan. And it generates a plan based upon information that it has about the query, about the objects, right? What kind of join do we have here between our tables? What indexes are available for us to use, and how could we use them? Could we seek them? Could we scan them? And there's a lot of other things that come into play, constraints, but statistics are also part of that. And they help decide what the optimizer is going to do, which it then uses to generate a query plan. And when we talk about, you'll hear people say sometimes cardinality, right? I talk about statistics and I talk about understanding the distribution of data. And you'll hear people talk about cardinality, which is and you'll hear a cardinality estimate, which is how much data do we think we're going to get back for a particular value. And I've said, somebody's got a question here about stats being a distribution of data. And so does that statistic include how much data? It includes the count of rows. So I'm going to actually go back here for a second to, I know it's a lot of clicking, to this histogram, right? But when I talk about the distribution of data here, I do have a count on the y-axis, right? For a last name, I know how many rows there are. And we get that in a statistic in SQL Server. And I'll show you that in the demo. So let me roll back up to where we were here. And we'll hop over to my demo. You should be able to see Management Studio. If you can't, let me know. And let's open this up here. And so in this demo, I'm running this on SQL Server 2016, but we would have the same behavior on 2015 of the AdventureWorks database, which I've restored. So I mentioned how do we look at statistics, and I could expand Object Explorer and I could go into my database and I could expand AdventureWorks and tables, but this is painful, right? This is time consuming. There's better ways to do this. So we used to be able to use something called SP Help Stats, which it's deprecated, but as we all know, deprecated often means it's going away, but it hasn't gone away yet. So here we see that I can do SP Help Stats for the sales order detail in the sales schema, and when I say all, that means I want to look at the statistics for indexes and I want to look at column level statistics. So these are the statistics for my indexes and these are my column level statistics. And I know they're column level because of the naming convention, the _WA_sys. That's a statistic that gets created automatically. _WA is for Washington, sys is for system. And then the second or the third set of numbers there, the 000s and the 3 is the column ID, and then the last set of numbers is the hex value for the object. But this is deprecated. So what I prefer to use is this bigger query, which has sysstats and joins to sysObjects and sysschema and sysindexes and gives us more information here. So let me highlight that whole query. And actually, I'm going to make a change here. because I want this to flip, and it's not. So let's run this. There we go. So I get a little bit more information because I've expanded the query to pull back more data. So I see what table's involved. And then if it's an index statistic, I see the index ID to which it's tied. And these column level statistics, they obviously aren't tied to an index, so the index ID is null. And then we see which columns exist for that statistic. So for product ID, it is just product ID because that's the only column in the index. For the first one, which is our primary key, which is our clustered index, you'll see that it has sales order ID and sales order detail ID. And if we scroll to the right, we have a little bit of additional information. Was it automatically created? Was it user created? Is it filtered? And if it is filtered, what's the definition? So again, this is just a query that I like to use to look to see what statistics exist for an object. The easiest way to look at an index for a table, just as an aside, and I mention it here because sometimes this is useful also when you're troubleshooting and looking at plans and looking at stats, is SP Help Index. And SP Help Index is nice. It only gives me minimal output. Kimberly has a version of SP Help Index that she's written, which you can download from her blog, and it gives us a lot more information. So it gives us the index ID, it gives us the index keys, and if there's any included columns, it lists those as well, along with the filter definition. And if you like to geek out on internals, it has the columns in the tree and in the leaf level as well. So if you're doing any tuning at all, or index consolidation, or looking at indexes, definitely recommend her version of Help Index. Now, if I want to look at a specific statistic and really understand what I'm looking at, you can use DBCC show statistics. And we input the name of the statistic, the name of the object, and then the name of the statistic. And by default, people tend to run it like this. They don't include this last little bit here. So let me just take that away for a second and show you what I get. In my output, I get 3 sections. I get the header information, I get the second section, which is called the density vector, and I get the third section, which is the histogram itself. So the header information gives me the name, it tells me when these were last updated, which is really important. This is one of the first things I tend to look at, when did we last update stats. And I also look at the rows and the rows sampled. Excuse me, how many rows were in the table at the time that stats were updated, and how many rows were sampled. And in this case, it's matching, which means that we had a full scan or 100% sample, but that's not always the case. The density vector I'm going to skip for now. The histogram is what's really interesting when we talk about understanding that distribution of data. And if I just wanted to look at the histogram by itself, I could come back here and run that same command and just say with histogram. And that will just give me the histogram as the output. So when we're talking about how many rows there are for a given value, this is where we can see that. So if we look at EQ rows means equal rows. So in this case, if we're looking at Anderson, which is S-O-N, we see that the EQ rows is 85. So there's 85 rows, or there were at the time that statistics were updated, there were 85 rows with the last name of Anderson. If we look at Black, there were 35 rows with the last name of Black. So the EQ rows is the information that the optimizer gets about how many rows would come back for that value. Now, what happens if I select a value in between, right? Like, let's say that I picked a last name that was somewhere in between Bennett and Black. I can't think of one off the top of my head. I'm sure there is one. So let's say that I was looking for a value in between here. What would the optimizer think? Well, there's this distinct range rows, and there's also range rows. And so between Bennett and Black, there are 33 rows. And between Bennett and Black, of those 33 rows, 20 of them are distinct, which means that for any given value in between Bennett and Black, there are 1.65 rows. So that's how the optimizer would say, okay, you gave me a value between Bennett and Black. I estimate that 1.65 rows are going to come back. If you gave me the value of blue, then 30 rows are going to come back based upon the statistic. So that's the histogram. That's the distribution of data, and that's the information that the optimizer has that it uses then to generate the cardinality estimate for a value. How much data is going to come back? Now, if we switch to a different object, which I'm going to use in more of my demo, so we're going to walk through that. I want to look at this index that's on product ID for the sales order detail table. So if I did the show statistics here, right, we'd get our three-part output, our header, our density vector, and our histogram. So we can see these were last updated in April, and this was a full scan at that time. And if I wanted to just look at, again, the histogram here, what do we have for data? Well, we can see that for something like a value, a product ID of 716, we have 1,076 rows. For 718, we have 219 rows. And notice that there's no entry here for 717. But that's probably what's between here, right? This is an integer column. And so there's 218 rows in between 716 and 718 with one unique value. So if you did a query and you said where product ID equals 717, it would estimate 218 rows based upon this histogram. Now, so you're aware, instead of using show statistics, you can use DMDB stats histogram in SQL Server 2016 and higher. So we're inputting the object ID, and then we're putting the stats ID here, the index ID. And if I run that query, I just get the histogram in the output. So this is a nice way to have to roll through that data sometimes rather than using DBCC show statistics. But we'll get the same thing here, right? If we look here between 716 and 718, we've got that 218 rows. So it just shows it in a slightly different format. And our other option for looking at some of that stats data is DMDB stats properties. And this is, again, 2008 R2, SP2 and higher, 2012 SP1 and higher, and then also 2014, 2016, 2017. And what we get here is something a little bit different. So I've joined to stats and objects and schemas because I want a little bit of additional information. But what we really get from this DMF is we get when stats were last updated. And we also get, in addition to the rows in the table and the rows sampled, we get this row modification. I haven't made any modifications here in this database, but this is what allows you to programmatically start to look at your statistics and figure out what's changed, when was something last updated, should I update it. Previously, you had to use DBCC show statistics and look at the header and kind of roll through that, which wasn't easy to do. It was very clumsy. The DMF gives us a much better method of looking at stats to understand when they were last updated and how much data has changed so that we can determine if we need to update them. So now that we know what exists, let's look at how the optimizer uses this. So if we take a query against sales order detail for a product ID of 732, let's highlight this, and we're just going to look at, first of all, we're going to look at our estimated execution plan. So when we look at our estimate, what we're interested in here, what we're interested in is, if we look at our index seek here, right, our predicate is product ID equals 732, and you'll see here that it estimates 130 rows. So let's run this with our actual plan enabled and see what we get. You'll notice that we do get, down here in the bottom right, 130 rows, and if we look at our plan, right, we can see that we have, since we have our actual plan, we get our estimate, and we also get our actual. So they match here. And this is, when people talk about cardinality estimate issues, this is one of the things that we're looking at. What do we have in terms of our estimates, and what do we have for our actuals? And you can only get the actual number of rows from the actual plan. And sometimes that's a little bit tricky. But when we talk about differences in what the optimizer expects and what actually comes back, this is where we're looking to get that information. So 732, it was estimating 130 rows. And if we look at show statistics, and we come down to our histogram here at the bottom for, not 730, 732, there we go. For 732, in fact, if we look at that, right, EQ rows is 130. So it looked at the histogram, and the information that's in the histogram matches what's in the table. And understand that doesn't always happen, right? If we look at when this was updated, it was last updated in April. Now that's because I restored a backup. But in your environment, your stats aren't updating every time there's a modification or new data is added, right? It's a Saturday night. Saturday night, 9 o'clock. A lot of maintenance probably runs on Saturday night, Sunday morning, maybe a little bit on Saturday morning, maybe some late Sunday night. When you come in Monday, assuming you just run maintenance once a week, when you come in Monday, the data that's in the database probably pretty well matches what the statistics say. But as data gets added and modified and deleted throughout the week, what's happened in the database and what data exists in the database may not be accurately represented in your statistic anymore. So whenever you're troubleshooting, one of the first things that's really easy to do is look to say, okay, what did the optimizer think it was going to get, and what did it actually get, and what does it say in the statistic, which is what we just went through right there. So it's saying, well, you're going to get 130 rows, and in fact we did. So what happens if we drop in a different value? What happens if we try 840? For 840 we get no rows back at all. And if we look in our execution plan, I don't want to look at the key lookup, I'll index seek. If we look at our execution, we say, well, it estimates 103 rows, but the actual is 0. Okay, so what's going on here? Did we delete a bunch of rows? Well, let's look at our histogram, and we're going to look at the value of 840 in the histogram. So 840 isn't here, right? What we see is, let's get right in here so we can see it. We have 838 and we have 843. And we don't have 840, right? It would be right in here. But we know that between 838 and 843, there are 207 rows, and there are 2 distinct values. Now, really, we could have 839, 840, 841, 842. We theoretically could have 4 distinct values, but we only have 2, and we have 207 rows total. So it says, okay, on average, there's 103.5 rows for each value in between, but it doesn't know what values are in between. So that's where it gets the estimate. So when we say product ID equals 840, it says, okay, I think there's 103.5 rows that are going to come back. That's what it estimates. There's only 0 that come back, right? And if we did this query between 839 and 842, there's our 207 rows. And then if we actually do a count based upon the ID, we'll see that we've got 47 rows for 839 and 160 rows for 841, right? Nothing at all for 840. Okay, so there's a question, and it's a great question because I'm going to get to the answer. So we're going to hold off, and I'm going to hop back here, and I'm going to keep going through this because we're going to talk about updates to stats. Now, I want to talk a little bit more about what we see in our plans. So we just looked, and we could see our rows, right? And there's other information in the plan. You may have looked at these before, you may not, but the plan tells us what SQL Server did, right? How did it decide to go get that information? What tables, indexes did it use? Did it do a seek or a scan, the operators, the cost, right? And if I hop back real quick, actually, where is it? There. If I hop back and I look at, if I run this query one more time, right, when we look at the plan, we see here that we have an index seek. And here we have a key lookup, and here we have a nested loop. That's our join type, right? And we have our cost estimates for each of these operators. So there's a ton of information that we get from a plan beyond just our estimates and our actuals. Now, the things that we don't get query duration, right? And there's actually some of this information we're starting to get in later versions. We didn't used to get I/O information. We now get some information in 2016 and 2017 and the latest service pack of 2014. Lock information does not show up. Weight stats, we do get in 2016 SP1 and higher, but I'm going to say use that with caution. We never get the actual cost. We always get estimated cost. And the point is that even though we can see a ton of information in the plan, we don't get everything. And so you can't just use those query plans on their own to tune queries. You've got to use other information as well. Now again, the estimates versus the actuals. The plan that we have in cache is the one that's been used. It's the one that keeps getting used as long as that query gets run over and over again. And so when you look at a plan that's in cache, you see the estimates, right? Estimated number of rows, estimated number of executions. But when you get the actual plan, then you get the estimates and the actuals, and typically it's the same plan that's in cache, but not always. And the estimates that we look at aren't always correct. Now, the basic example is that stats haven't been updated recently. But there's other reasons, right? Maybe there's a very skewed or uneven distribution of data. And so the histogram doesn't accurately represent what the data really looks like. Maybe the sampling rate is too low. Sometimes I've got some customers that have certain tables that have to be sampled at 100% because otherwise the optimizer doesn't have good information. There's an ascending keys issue, particularly in earlier versions of SQL Server where you need to use a trace flag to make sure that the optimizer understands that a key is ascending and that if the value doesn't exist in the histogram, it can still be unique. If you use table value parameters, there are issues related to estimates. Linked servers don't always give great info. Partitioned tables, there's some limitations there. And in-memory OLTP also has some limitations, particularly in the initial release in 2014. So be aware that this is one of the first things that you want to look for is to see, are my estimates accurate or not? So let's take a look here. So let's see here. Base. And I'm going to flip this again because I like having this on the second window. All right, so let me look at the estimates and the actuals here for this query against sales order detail for a particular product ID. So I get 58 rows back, and if I want to look at the execution plan, I have to make sure I include it. And so here for our estimate, we can see that it's 58. And our actual is 58 as well. That's great. But if I look at this, what do I have in terms of I/O? Well, I have a cost for I/O. And if I look at the properties, you'll see that I do get some I/O statistics here. And the reason I get this information is because of the version that I'm running. You'll not see this in every single version of SQL Server. You'll see it in 2016 and the latest version of 2014. But typically, in order to understand statistics information, you need to use statistics I/O. So set statistics I/O on. And when I run that, in addition to getting my plan, I have the messages tab. So I can see here that I have a scan count of 1, and I end up with 791 logical I/Os. And let's see, did I change? I did change that value. So just to come back here, right? This said 791 I/Os. If I come into my execution plan and I look at my index seek and I want to look at my I/O statistics over here, you'll see that this number of I/Os is a lot lower, 3. But if we look at my key lookup, I end up with 160 over here. Now, those two, what happens here is that I have 3 logical reads here, but this key lookup, which generates 160, actually does a key lookup 3 times, right? So 3 times 160 is what? I can't do it off the top of my head. 400 and some, right? So we still don't get quite to our 791, but it's additional I/O information in the plan that we didn't have before. Otherwise, you've got to use statistics I/O to take a look at that. Now, if we look at this query, product ID equals 871. In this query, we end up with a scan of our index instead of the index seek and the key lookup that we were seeing before. And in this case, it decided that that was a better option, and it knew that it was only going to return 2,000 rows, but the cost for returning those 2,000 rows through a seek with a lookup was probably more I/O than if it did the clustered index scan. So you look at that and you think, well, why didn't it use the index, right? Did it consider that non-clustered index that the other queries were using? So what you can do is you can load stats when you execute the query, and this is undocumented. So this is something that you want to do only in a test environment. You're not going to do it in production. You're not going to put this onto your query plans. But we can add these trace flags. 3604 is going to force the output to get printed, and then we can do 9292 and 9204. And I've got some notes on here about these. 9292 tells us the stats objects that are interesting. And then 9204 gives us the ones that are loaded. And actually in 2017, we get this information without using these trace flags. So that's kind of cool. But if we look here in the Messages tab, you can see here that we loaded the header for the sales order detail index ID 3, which is the one on product ID. And then it actually loaded the full statistic for this index as well. Now, it still ended up going with the index scan, but we can see that it did at least consider that. Okay, so let me see, I've got a couple questions here. Does the optimizer replace the existing cache plan with the actual one if they differ? No. So let's assume that I had pulled a plan from cache, and that plan had an index seek and a lookup. And then I ran the query on my machine, and if it's not using the plan that's in cache, if it for some reason generates a different plan, maybe because I use a literal value and the plan that's in cache has a parameter, the plan that I get as the actual plan does go into cache, but doesn't necessarily replace the one that is in there. Don't think that plans are replaced. A plan can be kicked out of cache because it's not being used, or a plan can be, you could force a recompile. So replace isn't quite the word that I would use there. But just because my actual plan that I get is different than the plan that's in cache doesn't mean that it's going to get rid of the plan that was in cache. Statistics I/O is available in Management Studio. And a logical read and physical read, when we're talking about that in terms of the output, physical read, it had to read from disk. Logical read, the data page existed in memory. If you wanted to, let me see what I did in here. If I actually forced it, and I want to force it to use the non-clustered index, I could do that. I could do that with a hint. But here's the thing: the optimizer is pretty smart, and it's not necessarily going to reduce I/O, because when I run this query returns 2,025 rows, and the amount of, let's see what it generates in terms of I/O. Let's turn this back on. Right. So if I run this one, in order for it to read through the index, it requires 1,200 reads. Now, if I did it this way with this plan, where this plan is an index seek and then a key lookup, remember that that value, this value here of 871, returned 2,500 rows. And so if I did 2,500 rows with this plan, it would mean it would find the row, and then it would go do a key lookup for each of those 2,500, which means it's going to do 2,500 random IOs. 2,500 random IOs is way more expensive than the 1,200 for scanning the clustered index. So even though you might think, well, it should be doing this, there's reasons behind the scenes that it might not be doing that. And that's what's really important to understand about SQL Server and how it works. And that's kind of a little bit off of what I was going to talk about today. Now, if I want to listen cache query, dmexec cached plans, and query plans and SQL text, and I'm searching basically just for that piece of text, and I'm probably going to get a lot of things back because I've done a bunch of variations here, right? And understand that in this case, because this is not parameterized, because I'm passing in literal values, there's textual matching in effect here. So each of these gets stored as their own query with their own plan in cache. So when I take plans which are in cache, right, this just has the estimates in there. It doesn't have the actuals. The only way to get the actuals is to capture the actual plan, such as we could do in Management Studio. Now, so for every variation, right, there's one plan. So if you look at this, I have 1, 2, 3, 4, 5, 6, 7, 8 queries that are basically exactly the same. The only difference is the input parameter that I have. So this can cause bloat, meaning I have a lot of queries that are pretty much exactly the same with probably almost the same plan, and it just fills up the plan cache. So this is why people sometimes say stored procedures are better. Now that's a very, very general statement, and I'm not saying that it's absolutely right. There are cases when an ad hoc query is beneficial. There are cases where a stored procedure is beneficial. If I wrapped this into a stored procedure, so I'll drop it if it exists, and then I'll go ahead and create a stored procedure that basically passes in that product ID. And then if I run the query, and I'm going to run it 3 times, right, with 3 different input values. I get 167 rows, I get 160 rows, I get 58 rows. And all of these have the same plan because that plan went into cache upon this first execution, and then it got used over and over again. Oh, actually, let's do the other 3. I'm going to execute it 6 times in total. And here, actually, I think I've got this point that I can make. Here we've got the 2,025 rows, we've got 110, and we've got 4,688. Check out the I/O here, right? 6,000 rows, or 6,000 IOs, 300 IOs, 14,000 IOs. So if I had left this as literal values, right, and did it for product ID 870 or 871, that's where that clustered index scan came into effect, and it was more efficient because it had less I/O. So I don't always want to say I want to force an index, right? You have to be really careful if you're going to do something like that. So now, if I look at the cache, we should see that I've got this procedure in here 6 times, because I've executed it 6 times, and the plan for that is index seek with the key lookup, and that's what gets used over and over again as long as that plan remains in cache, unless it recompiles for some reason. Okay, so let me hop over here. Now, one of the things we in the slides before I came into the demo is reasons why stats might not be accurate, right? They haven't been updated, random distribution of data, table value parameter. So we're going to look at this example with the table value parameter. So we're going to use this database, and we're going to declare a test table, and we're going to insert some data from sales order header into it. And so what happens here if I say less than 150? Select where less than 150. And let's make sure that I get my actual execution plan here. And you know what? Again, not liking that output. And I swear I said that, but let's run it again. Right? So what we see here is when I do my select from that where person ID greater than 50, right? It estimates 1 row here into that object. Now what happens if I change this to say greater than 285? Theoretically, there should be fewer rows in here, right? Notice that here for this select, it still estimates 1 row. So this is a challenge with table value parameters where it always estimates 1 row. Now if I put a recompile on here, what do we get instead? Let's look. Now we get a better estimate of 9,000 rows. Because when we force that with that recompile, we're basically saying, check and see how many rows are in there. But by default, without that, it's not going to look. So let's do this. We're gonna go back to how we had this, and then we're gonna add on to this. So separate from just selecting here, I'm also going to join between sales order detail and this test table based upon an order date, because I want you to see how this can start to cause bigger issues in the plan. Again, look at the select here in terms of the estimate. The estimate down here is 1 row, and if I look at my plan, and this is the plan that I'm really interested in, right? It's going to do a table scan, and it's going to estimate, right, that there's only 1 row. But you can see that the actual number of rows that came out was 10, and actually there's 31,000 rows in there that it had to read for all of that. So this doesn't show up, this doesn't look too awful. But what happens if I change it, and let's go to this? Is this still awful? Is this any worse? Right? I still get the same kind of thing where I'm getting 1 row and 10 rows actually read. But the challenge here is that my estimates and my actuals are really not accurate. And you'll notice that if I do a temp table instead, so we're going to do the same thing. We're going to create a temp table, we're going to insert into it, and we're going to say 150, and we're going to join. And when I do this, and I look at my plan, my estimate in terms of my data here is more accurate, right? Estimated number of rows, 11.3. Actual is 10. So I get a better estimate when I use the temp table as opposed to using the table variable. Now that doesn't mean that you must use temp tables in place of table variables. There are select cases where both are appropriate. You get better statistics by default with the temp table. With the table variable, you're going to get a very low number in terms of your estimate. And if you're pushing huge rows, thousands and thousands of rows into a table variable, and then you're joining on it, your estimates are going to be very skewed and very off. So what we're looking for is discrepancies between that estimate and that actual. All right. Now, somehow, I didn't want to go all the way there. Oh, we're just talking, I'm going to talk about this first, then I'll come back to the demo, the last demo that I've got. So I want to talk about updating stats, because when we find discrepancies in estimates and actuals, one of the things that tends to happen is people think, oh, stats are bad. And out-of-date stats aren't the only reason that your estimates don't match your actuals, as we just saw with the table variables. So when do stats get updated? Well, every time you rebuild an index, the statistic for that index gets updated with a full scan, and it's just the statistic for that index. So if I have 3 indexes on a table and I rebuild all 3 of those indexes, then the 3 stats for those 3 indexes get updated. They don't touch the column level stats, right? It only updates the index stats, and it's the equivalent of a full scan, which is great. Now I can update them manually, which I can do issuing an update statistics command. I can do that as part of a job, right? When I say manually, I don't mean that I'm going into Management Studio and I'm typing update statistics for every statistic and updating it. When I say manually, I mean I've got an agent job that runs on a regular basis that updates stats for me using the update statistics command. Now there's another command called SP update stats. I do not like this command. I don't recommend it because it will update statistics for a stat if only 1 row has changed. And if only 1 row has changed, I probably don't need to update all the statistics, right? So I like to programmatically look at statistics and determine if they need to be updated. Now stats can get updated automatically. Someone had asked a question about this earlier, right? And this has been around since SQL Server 7.0. That's when automatic updates were introduced. Still there today. So they'll automatically update when a certain amount of data has changed, and it's typically not a full scan. Unless the table is 8 megs or less, it's a sample. And the updates to statistics can happen immediately, or it can happen asynchronously. So there's a database setting which is update stats asynchronously, which means that if it needs to update a stat, it won't update it at that moment when the stat gets invoked. It will delay that, and it will do it after the fact. And this is in effect for index column and filtered statistics. So for 2014 and below, the threshold is 500 rows plus 20% of the rows in the table have changed. That's when an automatic update will kick in. And you can use trace flag 2371 in 2008 R2 SP1 and higher to lower that threshold to something even lower. Because if you think about 27% of the rows for a table with 10 million rows, it's actually pretty high. In SQL Server 2016, it's the same threshold as the trace flag of 2371 as long as you're using compat mode 130. So the automatic update is, in my opinion, it's a safety, because I really want you to manually manage your statistics. I want you to have a job that after you do any index rebuilds goes in and says, hey, are any of my stats woefully out of date or has a lot of data changed? And if so, I'm going to update them. Now, how do my statistics tie into my query plans and what happens to them? So a query gets used until it gets aged out or it gets invalidated. So remember when we had our stored procedure and I ran that stored procedure the first time and that plan went into cache, every subsequent execution used that same plan. So that'll get reused until it ages out. And when it ages out, it's based on a cost-based approach, which says as long as that plan gets used, then the cost is above zero. But if we stop running that query and that plan doesn't get used, then the cost is going to approach zero. And when I start to not have enough space for everything in the plan cache, any plan that's close to zero, I'm going to kick that out, right? I'm going to age that out. So that's what we mean by aging out. Now, invalidating is a little bit different here. So your database is changing, right? Maybe your schema stays the same, but data is changing, right? And occasionally there's schema changes that occur as well. So because of this, because data is changing, because there may be a change to the schema, a query plan may not be appropriate after a certain amount of time, right? I don't expect that your query plans are static forever and ever and ever. And so SQL Server's got some methods in place that says, oh, this change has occurred, and so therefore this plan that we've been using, it's no longer valid, right? We're going to say it's invalid, which means that the next time you go to run that query, it's going to see that the plan's invalid, and it's going to generate a plan. And it could be the exact same plan as before. It could be completely different. The idea is that there's something that's changed, and so it wants to make sure that the plan that it has is best for that change. Now, what invalidates a plan? Well, if I change a table or a view, if I change a stored procedure, any plans associated with those objects get invalidated. If I change an index that's in a plan or I drop an index, the plan's invalidated. If I update a statistic where a stat is used in a plan, then the plan gets invalidated. If I've got a lot of rows in the inserted or deleted tables for tables with triggers, plans can get invalidated. Or if I specifically do an SP recompile or I use with recompile, my plans are invalid. So there's a lot of cases there, right? So this is why when you run a query on Monday, the query that you run on Friday might end up with a different plan than what you ran on Monday, because a plan could have gotten invalidated along the way because stats updated, or because maybe somebody made a change to a stored procedure or to the object. Now, why would we invalidate? Because there's changes, right? And most of those recompiles are to make sure that the statement's correct, and because we could potentially get a faster plan. Now, it doesn't mean that it will be, it doesn't guarantee that it will be faster or better, but we want to make sure that it's at least accurate. And if you want to understand when recompiles occur. You can track them with extended events. If you're using 2000 ARC2 and before, you can use trace. But you can use extended events to track them. So I want to look at cases where we have a recompile or something gets invalidated here. So let's look at our last demo here, and I'm going to set, where's my query? There we go. I'm going to fix this right now before I do anything else. All right, so back in 2016. So what we're going to do is we've got our, actually I'm going to kind of go a little bit off script here. And let's take a look to see what we have in cache right now for sales order detail, right? We've got our create procedure here, and then we have all these different variations that we've run for product ID. And if I change some data, so I'm going to load some data in here from a text file. This adds 24,000 rows. And so if you remember, in this case, in our output, hold on, sorry, when we looked at our stored procedure here, right, if you remember, that plan was with the key lookup. And so now, what happens if we rerun that procedure again? And I'm going to run it with 870, which if you remember was a non-unique value. And so when I run that now, if I can only remember that execution plan originally. When I run it now, you'll see that now I have a clustered index scan because we had the plan in cache, which was the index seek with the lookup. But then we added some data. And when we went to run this stored procedure again, the stored procedure said, oh, you added some data and you updated statistics, which means that my plan's invalid. So now when you run the stored procedure, I'm going to generate a new plan, and it generated that clustered index scan. And so if we look in the plan cache now, we see that we have our create procedure, and we've executed it twice, right? I ran it one time and realized I didn't have my plan on, and then I ran it again, and we can see it's that clustered index scan. So because I added data, stats became out of date, and so when I went to run the query again, it updated stats and it generated a new plan, right? So it recompiled. So if I just double check here, auto update statistics is enabled for AdventureWorks, and you can, here's one case where I will go into the UI, right, just as a reminder. If we come onto our options tab and we look at auto update here, right, auto update statistics is set to true. I recommend leaving that enabled. Again, it's a safety. Auto create statistics set to true. Both of these are set to true by default for a new database, and I recommend leaving them set to true. So that was enabled. And in terms of query performance now, if I go run that stored procedure over and over and over and over again, it's going to run the clustered index scan every single time, which means it's going to require 2,300 IOs. So what I've described is a parameter sensitivity issue, right? Because when I put in one parameter, I get a clustered index scan. When I put in a different parameter, I get an index seek with a key lookup. And for those different literal values, one plan is more optimal than another. But if I have it in a stored procedure, this plan gets into cache and it gets reused over and over and over again, which the clustered index scan might not be ideal for every single value, right? Now, let's pretend that we're going along, and this has all happened in the background, right? And we think, we find out that, okay, there's a performance issue, right? And the performance issue is that this thing is running as a clustered index scan. And in our system, it's only 2,300 IOs, but in your system, it could be 100,000 or 230,000 IOs. So if that happens, you might be like, well, jeepers, maybe somebody dropped an index, right? So let me check, do we have the index? Because I know we have an index on product ID, and you see, oh, well, that index is still there, so I'm not 100% sure why we're not using it. So maybe my stats are out of date. So you take a look and you're like, okay, here's whoa, you know, this one hasn't been updated since April. Well, this is the one that I want it to use, right? And it looks like it was just updated, but right? There's 146,000 rows and it only sampled about half of them, right? It didn't do a full scan. So maybe my problem is that it needs a full scan. And you'll notice here that my row modifications here says 0, right? So maybe this is what happens, right? Is you're like, oh, stats are out of date, or you think, gee, it wasn't a full scan. Let me go ahead and update statistics. And as it said in the slide, an update of statistics should force a recompile, right? Well, let's see what happens. Let's turn on my plan so you can see what really happens. I still have the clustered index scan. So let me look in the cache. Let me 6 times and then another 6 times, and if it recompiled, it should be really low. But no, this execution counts at like 26. This didn't recompile. Okay. So what you might do is this. Let me just free procedure cache. Let me just get rid of the plans in cache, right? And I have a sad panda here, right? Because this gets rid of all the plans in cache. Not just the one that I had, all of them. So this, in a panic situation, might be something you do. And then you might, who knows what's happening in the background at that point. But depending upon what value that query gets executed with the first time, you could still end up with the same plan in there that you had before. And you also probably spiked CPU on the server, because whenever you have to go through and compile all those queries, that requires a lot of CPU. So what's going on here, really? There's something I'm not telling you on purpose here, because I want you to think about it, right? So we tried to free procedure cache. We could have just removed that one plan from the cache. In a worst case scenario, you restart the instance, which is not great because you lose a bunch of data. So maybe we look at the plan in a little bit more detail. So let me find the plan get here from cache, which it's this clustered index scan. Okay, and it's estimating 146,000 rows, and that it has to read back. So what do we have here? Let me look at my statistics for product ID, right? What do I have? 4,800 rows, right? It doesn't think it's unique, which is why it's scanning the index instead. And if I look at all the product IDs in there, right, 870 is the one with the most number of rows. So there's something that Kimberly talks about, which is a tipping point, a point between where seeking is no longer more efficient and scanning becomes more efficient. And if we look at these different literal values, 732, 870, 739, and we run the query in this manner, right? When we get 166 rows back, we get an index seek. When we're getting a few thousand rows, we get the clustered index scan, right? So again, parameter sensitive query. But why is it, right? Parameter sensitive issue. Why didn't stats address it? I know that in cache right now, I have the full scan, the plan that has the full scan. So if I update statistics with a full scan, this should invalidate that plan, right? I told you that. So let's just double check, show statistics, not new query. And we can see it's just updated, 146,000 rows. And now if I run my stored procedure again, and this is a non-unique value, I'm going to run it one time, right? It only returns 205 rows. It's still using that clustered index scan plan. And if I look here in cache, right, my execution count is still going up. And so what's happening, right? There was a change in SQL Server 2012. If I update stats, if I issue an update of statistics, but no rows have actually changed, it will go ahead and update stats, but it won't invalidate your plan, which is what's happening here, right? So I update statistics. We'll do it again. I verify that they've been updated, right? 10:04 p.m. We're running over. Thanks for bearing with me. I'll rerun this stored procedure 6 times. It's going to use that same plan. And if I look at my execution count, this should be at least 13 at this point, right? Because no rows have changed. So it'll go and it'll update stats. It'll do the work, but it's not going to invalidate my plan. Now, let me change one row of data. Hopefully just one row. Yep, one row. Now, update stats again. And if I look at my show statistics, right, updated again, 10:05 p.m. now. Rerun my stored procedure. This is a unique value. Now I get a different plan. So this is something to be aware of. And if I look at my execution count, this should be at 1. Not my create trigger. There. Create procedure, right? Executed 1 time. So this is a really important note. I'm going to hop back to the slides because I've got it noted in there. In SQL Server 2012 and higher, when stats are updated, if no data has changed, plans will not invalidate. Stats will still get updated. It'll still go through the work, but it's not going to invalidate the plans. In 2008 R2 and below, if you had auto update stats enabled and you updated stats, plans were invalidated. Period. That's it. But interestingly enough, if you had auto update stats disabled and you updated statistics, plans were not invalidated. So these are some kind of significant differences in what happens with invalidation in statistics between 2008 R2 and below and 2012 and higher. And it's important to understand when stats update and what happens based upon your version. Okay? One of the things that you could have done if you're running 2008 R2 and below and you have auto update stats disabled for some reason, you can do a SP recompile to your stats script so that it will recompile every object that has stats updated in it. So, my point, when you go back to the office, hopefully you are not in the office at 10:06 p.m. on a Saturday evening, 10:06 Eastern Time, but when you're back in the office, right? Understand that stats are very important to the optimizer. Again, I don't like to rely on auto update. I want you to have a plan in place, a job in place that updates statistics. And when you get a query plan for a query, it's going to get reused until it ages out or until it gets invalidated. And updating stats will invalidate a plan unless no data has changed, if you're on 2012 and higher, or if you're on 2008 R2 and below and you have auto update stats disabled, updating stats won't invalidate. So my point, my takeaway is really don't just blindly update stats as your initial step in troubleshooting. You have to understand what the real issue is. Now, a couple of notes, what I call the kitchen sink, which is a bunch of just things that have come up as interesting points. You can do concurrent statistics updates using traceflag 7471, and that was ported back to 2014. You can do parallel updates of stats in SQL Server 2016 as long as you're in compat mode 130. And I had mentioned that stats might not be accurate for in-memory objects. Those do get updated automatically in 2016 as long as you're on compat mode 130. Now, I've got a couple of resource slides here, but I've got a couple questions. One of them, if estimates are way off, does that affect performance? It absolutely can, which is why it's an easy place to start and something to check. Do the rows return get slower as opposed to near accurate? It's not necessarily that rows get returned slower. One of the things that's really important to think about when you're looking at a plan here is if I look at these plans, these lines, right, are pretty thin. Estimated number of rows, 90. There's one row coming back for each lookup. If this estimate is way off, right, instead of estimating, instead of returning 90 rows, let's say it actually returns 90,000, right, then this is a big, thick line that comes out of here. So is the data going slower? Well, technically, I suppose, because it's got a lot more data to read, right, but it's not going to be slower for any other reason other than it has more data to read. So the challenge is that if your estimates are off, you can get a lot of data flowing through the plan that shouldn't be. Since a table variable doesn't contribute much. So a table variable, in terms of the estimate, remember, it just estimates, whew, said that. It just estimates, did it again. I'm a little tired, I think I must admit, right? We just of one row here. And in this case, even though it returned 10 rows, note that it had to read 31,000. So the question I'm being asked is, should I not use these? And you're very rarely going to get a yes or a no out of me. And the follow-up question is, should I always use temp tables? A table variable, if you're using if it's a small amount of data that's being inserted, having a row estimate off is not awful, right? If it's estimating one row and it's actually 10, and there's only 10 rows in there, and there's always 10 rows in there, then the table variable isn't awful. But if the amount of data that gets inserted into the table variable is large, or it fluctuates, it's inconsistent, you have no idea, then I would say a temp table is probably a better option because you're going to have better statistics on that. So very rarely is there an always. There's not an always here where I would say always do this or always do that. You need to understand how much data you're putting in there and also what you're joining to. Hopefully that helps. Okay. So these were some more resources. I got a lot of resources in because, again, I really like talking about statistics. But that was the end of my content. So I went through all the questions. Are there any other questions?
Yes, I'm going to do it.
Hey, Aaron. I was wondering if frequent drop and recreate index, would that affect the statistics?
Yes, why would you do that?
I was thinking in a scenario of ETL.
In that case, you're loading data in and then you're creating statistics, correct? Right. Or you're creating indexes, sorry. In that scenario, in an ETL, extract, transform, and load, right, you're pushing a bunch of data into an object, probably a heap, because that's the fastest way to get it in. And then you're going to put an index on it for whatever queries you run after that. Creating that index creates statistics with a full scan, and presumably once you've loaded that data in, you're not maybe doing a lot of changes to it. So in that scenario, the drop and the create is fine because you're changing, you're truly removing all the data, pushing new data in, create the index. Drop the index, remove all the data, push everything in. That's totally fine in that scenario. In an OLTP environment, I would say that's not a typical pattern. Does that help?
Yeah. So in that case, would the engine knows, oh, the data has not been changed compared to what's been dropped before?
All the engine knows is what it sees in the statistic at that point in time. It doesn't maintain any kind of a history. So if Monday morning you run a process that loads data in and creates indexes, at that point stats will get created. Assuming no data gets changed throughout the day, it's going to use that stat, and that stat's not going to change. Tuesday morning comes along. You drop all those tables, you create new ones, you load data in, you create the indexes. It has information at that point. That's the information that it uses.
So it doesn't keep a history, right?
It does not keep any history about statistics, no.
Okay.
All right, there was another question. If I have two indexes with the same key columns in a different order, how does the optimizer choose the right index? Define the right index. It will choose an index depending upon the statistics, and it will also depend upon your predicate and your join columns. So there's a lot of it depends in there. You have to know the query and the join.
Oh, I was wondering, for all these queries, would you be able to share with us, or?
Sure. Can I send them to you and then you can post them?
Yeah, I will definitely post it on our website.
Okay.
Also, slides on
Yep.
the slide deck. Okay,
Sure.
wonderful. Thank you so much.
Mm-hmm.
Do you
I got
have
one more. I'll
any?
take one more question, and this will be the last one. If you've got other ones after that, feel free to email me. For the case of a parameter-sensitive query with a stored procedure, if I have an ID that's got 10,000 rows and an ID that has 1 row, SQL Server will reuse the plan. Yes, which is exactly what I showed. It depends upon which value it uses for that initial execution. So if the first time the query executes, it uses the non-unique value, the value that has 10,000 rows. If that plan is a scan, then even when you execute the store procedure with the non-unique values or with the unique values, it's still using the scan because that's the query that's in the plan cache.
All right.
All right.
Okay,
Well, I'll go ahead and I'll get the slides and the scripts over to
Sarah.
Sarah for. Yep.
Yeah. Okay, cool. If anybody has additional questions, feel free to email Erin directly, or you can send that to me through Saturday Night SQL at SQLpass.org. Then I'll forward your questions to Erin. Otherwise, thank you so much, Erin, for taking your Saturday night to share this knowledge with us. I do learn a lot. Really appreciate that.
Oh, no problem. Thanks to all of you for joining and have a great rest of the weekend.
Thank
Thank
you,
you.
Erin.
Bye.
Thank you, everybody. Bye.
Bye.